Alright, in this video we're going to determine whether or not given ordered pairs are solutions to inequalities. So to determine whether a point or ordered pair is a part of the solution to an inequality given the actual inequality like we have right here, you substitute, keyword substitute the ordered pair in for x and y and see if it produces a true statement. So simply what we have here, we have y is less than 2x plus 6. Here's our first point. Now, remember, ordered pairs, x, y. Okay, reduce that down a little bit, x, y. So now we go back up to our equation, or our inequality, our y. So we have y is less than 2x plus 6. So now I'm going to substitute my 0, 3 in, my x and y. So y is 3. Is that less than 2 times 0, x is 0, plus 6? Well, we have 3 is less than 2 times 0, 0 plus 6, so 0 plus 6 is 3 less than 6, and that is true. So either put true or yes. Now notice the directions say, and state or show why. Well, that's what you're doing right there. You're just showing me the work, and you're saying, see, yep, I have 3 is less than 6, it's true. It works. All right, next one. We have x is 10, y is 1. So now I plug those into the inequality up there. I have y, which is 1, is less than 2 times x, which is 10, plus 6 is 1 less than 2 times 10 is 20, plus 6. I think we're going to get this as a true, right? 1 is less than 26, true. Or yes, either way. Those are your solutions. All right, and the last one, we have, let's see, our x, our y. So 0 less than 2 times a minus 3 plus 6. Well, 0 less than 2 times a minus 3, that's a minus 6, plus 6 is 0 less than 0. Little trick question here, is 0 less than 0? And that is false. It is not less than. It's equal to it. It is not less than it. So that would be false or no. Okay, the next type problem, we have a little bit more complicated inequality, but really the same setup. All right, same idea, x, y. All right, plug it. Let's see, 0 in for x, so 2 times 0, plus 0 in for y, that's 0. Is that greater than or equal to 8? 2 times 0 is, well, this is all 0. Is that greater than or equal to 8? Nope, false. Or no, does not work. Next one. Let's see, x is 5. Here's my x, here's my y. X is 5, so I have 2 times 5 plus, oh, that's a negative 1. Is that greater than or equal to 8? Well, 2 times 5 is 10. That's minus 1. Is that greater than or equal to 8? 9 greater than or equal to 8? True. So yes, it is a solution. And our last case here, here's my x, here's my y. So I plug that in. Let's see, I have 2 times x, which is 3, plus y, which is 2. Is that greater than or equal to 8? Well, you're going to get 6 plus 2 greater than or equal to 8. Is 8 greater than or equal to 8? In this case, that is true because it is equals to it. It does work. All right, next scenario. What happens if we have graphs? Well, to determine whether a point or ordered pair is part of the solution to an inequality given the actual graph, like I have right here, here's my actual graph, you plot the point, the ordered pair, and see if it's part of the shaded area, the solution. And that's simply all you have to do. You just plot these points and see if they're part of the shaded area. The shaded area, as you're going to learn in the next videos, represents your actual solution set, these points over here. So, very easy. I just start with 0, 0. Well, 0, 0 is right there. I plot the point. Is that part of my solution set? Solution set shaded area. No. How about negative 2, 1? Negative 2, 1's right there. That's part of it. Yep. So that'd be a yes. How about 2, 2? Well, 2, 2 is way over here. No, not even close. How about a negative 2, 2? That is right there. Notice I give you a little help here. It's on the dotted line. Now this is a dotted line, and you're going to learn in inequalities, graphing two-dimensional inequalities, a dotted line means it's not included in the solution. So it's like when you did your inequalities earlier and you had an open circle on a number line. It didn't include that number. Well, a dotted line on a graph means you don't include anything on that graph. So this point's on that line, that's on that, or it's not part of the solution. It's on the line, dotted line, but it's not actually part of the solution. So that would be a no. Alright, and I'm going to show you, if I can get to it here, what actually happened to our other one that we did earlier. Our 2x plus y is greater than or equal to 8. If you notice, we had to point 0, 0, we had to point 5, negative 1, and we had to point 3, 2. Okay, you notice this is what would have happened if we would have done that problem by just simply graphing. Notice we came up with no, not part of the solution. That's a no. This one was a yes. Remember that last one was on the line, right on the line, but it had an equals with it, equals right there. So since it had an equals, it is actually part of the solution set. And that's an important thing to remember. Alright, when you go back and do these, if you just have a less than or greater than, write it out. If I just have a less than or greater than, and it's on that, it makes a dotted line, and it's on that line, a point that I plot is on that line, is not part of the solution set. Now, if I have the equals with it, and it's on that line, it is part of the solution set. Hope that helps you get going here, and good luck on the worksheet.